All right, guys, let's do some examples of mole conversions. Today we're just doing moles to particles and particles to moles, and I'm going to do some examples here. So I'm going to go ahead and make a copy of our assignment. So I'm going to show you how you can show your work in a Google Doc. I know with math it can be a little bit tricky to do it virtually, but thankfully we can insert some tools to help us. So I'm going to go back into my assignment and I'm going to pull up my calculator too. If you have a scientific calculator, please feel free to use it at home. But if not, this one works perfectly well. I'm going to show you how to type everything in so that everything computes correctly. Okay, so here we have 6 problems. I'm going to do one of each. So I'm going to do one, which is particles, moles to particles, and then I'm going to do number 4, which is particles to moles. So they're 2 different conversions, but the conversion factor is the same. But I'm going to do 2 examples for you. So you'll be able to use example 1 to help you do 2 and 3, and then you'll be able to use example 4 to help you do 5 and 6. Okay? So this is our intro to STOIC. We're going from moles to particles or particles to mole. Either way, it's going to be the same process. We just have to pay attention to what units we're converting between so that we know what goes where. Okay, so for the first part, we're determining the number of particles in each of the following. So we're going from moles to particles. And for these examples, the conversion factor we're using here is always going to be Avogadro's number. So our conversion factor will always be 1 mole is equal to 6.022 times 10 to the 23rd. So this is going to be the setup that we're going to use. We're going to use those steps that we just went over in your slideshow for today. So let's start. What we always do when we set up one of these problems is we start with what we know. Okay, I'm going to use fractions here. And I'm also going to put what I know over 1 to help us visualize it a little bit better. You don't have to put it over 1. You could start by just typing out 3.54 moles, but the way I'm going to do it is going to help us keep everything kind of just easily available to see with our eyes to see where everything's going. So I'm going to go to Insert. I'm going to go to Equation. And up here you'll see these equation symbols. We're going to do the math operations and we're going to get a fraction. Okay, so that's going to help us with this. So what I know I'm starting with 3.54 moles of CO2. Okay, and I'm going to put that over 1 because it's assumed 1 in the bottom. Oops. All right, now I have to do my conversion factor. So I know I'm going to multiply this by a conversion factor. Okay, so I'm going to go to New Equation, and I'm going to get another fraction. Now remember, our conversion factor for all of these is 1 mole is equal to 6.022 times 10 to the 23rd. Okay, but we have to decide where moles and where particles go. Now, anytime we're doing a conversion, so stoichiometry, dimensional analysis, however you want to call it, we need to make sure the unit we want to end with is on top and the unit that we want to eliminate is on the bottom. Okay, we want particles, so that means we want to eliminate our moles. Okay, so I know that my moles need to go on the bottom so that this and this will cancel out, and I know I want my particles on the top. Okay, so particles go on the top because that's what we want to end with. Moles go on the bottom because that's what I want to eliminate. Okay, now we need our conversion factor, which is Avogadro's number. So I know 1 mole, and the 1 will always go with the mole here. It doesn't matter if it's in the top or the bottom. 1 mole will always be equal to 6.022 times 10. I'm just going to use the little up symbol for this. And you can get that little up arrow by clicking Shift and then 6 on your keyboard. Should be able to give you that. Oh. Maybe not. Hold on 1 second. times 10 to the 23rd. Okay, so here we have 3.54 moles of CO2 over 1 times 6.022 times 10 to the 23rd particles. Okay, now we have this set up correctly. Now we just have to do our math. So our moles are going to cancel, and we're going to be left with particles. Now when you're doing fractional math, the best thing to do is just multiply through on the top, multiply through on the bottom, and then divide. So I'm going to go ahead and show you what that'll look like. So if we multiply through on the bottom, we'll have 1, and the mole eliminates, so that will be gone. Now for the top, we have to do 3.54 times 6.022 times 10 to the 23rd. So this is where our calculator comes into play. So the first thing I'm going to do is Avogadro's number. So I'm going to start with the parentheses just so everything calculates correctly. So 6.022 times 10 to the 23rd. And then, of course, I'm going to click here so that this does right. All right, so there's our 6.022 times 10 to the 23rd times 3.54 moles. And here is our answer. And for you guys, you can round to the nearest hundredth. So I'll round it to the 2.13. So our answer is 2.13 times 10 to the 24th. Okay, so I'm going to come back here. 2.13 times 10 to the 24th. Okay, and again, to get the exponent here, you can just do shift and then hit the 6, that's the up arrow, and it'll give you that in the math operation. Okay, now if you had another number other than 1 here, you would have to divide, but since it's all divided by 1, our final answer is just going to be that 2.13 times 10 to the 24th. Okay, and that is your answer for number 1. So the biggest thing to do, and again, like if it helps, if you write this on a separate sheet and then and then type it in, you can do that. But just to help us visualize here, just so we can see, so the moles have disappeared, so our unit here would be particles. Okay, so the moles got eliminated. So in chemistry, we never want any naked numbers, so I'm going to add my units. So this means that in 3.54 moles of CO2, there are 2.13 times 10 to the 24 particles. Okay, and that's that one. So use this example to help you do 2 and 3, and now let's go the opposite direction. The process is going to be the same, but for 4 through 6, we're doing the moles in each. So same thing, we're going to start with what we know. So I'm going to go ahead and get my equation here. We know we have 3.25 times 10 to the 25th atoms. Okay. And that's all over 1, just to help us kind of visualize that. Again, if you were doing this by hand on paper, you wouldn't have to put it over the 1, but it helps us when we go to do our math just to help us visualize that. Okay, now we have to do our conversion factor. So we're going to multiply again, but this time we're going from atoms to moles. And in the same sense that we want to make sure whatever unit we want to eliminate goes on the bottom, same thing goes here, right? So we're going to do atoms on the bottom because we want our atoms to eliminate, and we're going to do moles on the top because we want our moles left over. So here we're going to use that same conversion factor, which is Avogadro's number. Remember, the 1 always goes with the mole when we're doing these. Okay, 1 mole. Again, like I said before, it doesn't matter that the moles are in the numerator now. The 1 is always going to go with the mole. 1 mole in the top, and our conversion factor is 6.022 times 10 to the 23rd. Okay, that is your conversion factor. So our atoms are going to eliminate and we're going to be left with moles at the end of this. But this is a little bit different now because we're going to have to divide, right? So let's go ahead and type it so we know. So we're going to have 2.25 times 10 to the 25th. Okay, that's in our numerator because that times 1 is 2.25 times 10 to the 25th moles. And then our atoms are eliminated. So in the bottom, sorry, sometimes these can be tricky, we're going to have 6.022 times 10 to the 23rd. And we don't put atoms because the atoms are eliminated, right? These units have canceled out. Now this is different because instead of multiplying across the top and having one on the bottom, we have a division problem here. So we have to do 2.25 times 10 to the 25th divided by 6.022 times 10 to the 23rd. So let's go do that. 2.25 times 10 to the 25th. Let me clear this. So our first number, actually, let me go ahead and get my parentheses because we want it all to calculate. 2.25 times 10 to the 25th divided by Avogadro's number, which is 6.022 times 10 to the 23rd. And our answer here is 37.363. We'll just go ahead and round it to that 0.36, 37.36. So 37 moles. And again, no naked number, we want to add that unit. This makes sense, right? Because the moles are in large particles. Remember, 1 mole is equal to 6.022 times 10 to the 23rd. So if you're going from moles to particles, you're going to have a larger number. If you're going from particles to moles, you're going to have a smaller number, okay? So there's your 2 examples. You have one for moles to particles and one for particles to moles. So you guys have the job of doing 2 more examples of each. It's set up exactly the same way. So if you follow these examples exactly, you should come to the correct answers at the end. But if you're still having trouble and you need some additional help, or if you need some help walking through these, just let me know.